friends, today our topic is a doubly linked list in data structures. So doubly linked list is nothing but a collection of node as same as in the linked list, a single linked list. The same concept used here. This is also an abstract data type. So linked list is a collection of node, but in doubly linked list the node have some different format, because the singly linked list have one connection with the other node. The connections only in forward in single linked list. So this is known as doubly forward linked list. That means the list of nodes connected with both front and back of the node. That is known as doubly linked list. They have a double connection in front side and back side. So see this diagram. So each node have three parts. The first parts for make a connection with the previous node. The second part for storing our data, and the third part it used to connect the node to the next node. Okay. So each node have a three parts. The first part is a pointer type data, so used to connect with the previous node. The second part used to store our data. The third part is also a pointer variable, pointer type variable. It is used to make the connection with the next node. So this is the basic node concept in the doubly linked list. So this is the structure representation for a node. So already we tell about the node. Each node have three parts. The first part for data, and the remaining part next and back is a pointer type variable. Okay, this is a node. Using structure we define the node. So see this diagram. This is a simple example. Okay, so my first data David, second data Joshua, the third data Lekha, then final, then last date is Meera. Okay, here each node have only one data. Also the data are connected with both front and back side. So here this is the list data. This is my starting node. The starting node, that means head node. The head node point the David. The final node, they have a no pointer. In the final node, the next, there is a no next pointer. Here we have only null. Listen, how can you find which one is the starting node or which one is the ending node in doubly linked list? We have separate content for starting node. So which one is the first node? There is a no previous pointer in the starting node. Same concept in the ending node. There is a no next pointer at the ending node, as shown in the example figure. Okay, there is a no previous pointer for the starting node. At the same time, there is a no next pointer for the ending node. So instead of next pointer, we use null character to tell this is the last node. This is the last our data. Okay, listen. Same as single linked list, we can do so many operations in the doubly linked list. The first one is searching for particular element. That means travel from starting to at end of the linked list. The second one is insert particular element at beginning, at middle, at end. This is the insert operation. That means insert in anywhere. Doubly linked list you can insert at anywhere, starting point, ending point, or at the middle. Same as delete a particular element. Maybe it placed in final place, last place, or middle of the list, or first element of the list. So these are the list of operations done in doubly linked list. Now we see about a simple example for inserting a particular element in doubly linked list. Doubly linked list, here I choose the position at middle. So insert a new element at middle. The diagram represents the 4 steps. Okay, by using this 4 step I can insert the particular element at middle. Okay, see the first step. So the node Joshua Myron. Okay, so between this I want to insert the new node Leka. So I create a node with the name of Leka. It have a previous pointer, it have the next pointer. Okay, previous and next. What happened? I want to choose the position. Maybe I want to choose the position 2. So Joshua is the first element, Leka is second element, means I want to put the element at the second place. Okay. So now what happened? So new node back equal to location back. Okay. So my location is 2. So 2 what a back side. 2 what a back. 2 what a previous position is. How can I find? So location back pointer. Which one is pointed by location back? At the same place is pointed by new node's back pointer. Then next, new node next equal to location. So new node location is equal to location. So new node points the current position. Okay. Next. So the location node back must point to the new node. Then only it makes the connection. The location node back pointer connect to the new node. Then we can make this connection. So location is nothing but is a one of the node. It travels from starting up to the current position. Current position means if you want to insert the data at second position means the locations are the current locations equal to 2. If you want to locate the new element in the first position means the location value is 1. So we first fetch the location. After fetching the correct location, we rearrange the both pointers, back and front pointers, change to new node. It make a connection with new node. That's all. It's very, very easy. Just a minute. Okay. So one more example. If you want to insert the data, new data John, already 2 nodes are present in the queue. The third data John I want to insert. What happened? So what happened? We want to insert John. What happened? We first change the robot's next pointer. We want to insert the robot next pointer. It point to the new node. So second one, so new node next equal to null. So new node next equal to null. There is no element after the John. So John next equal to null for insert. If you insert one more element, Sharon, what happened? We add next to the last element. The next pointer connect to Sharon. So Sharon's next pointer null. Sharon's back pointer connect to robot. Okay. So only you give data for 2 pointers. Back pointers point to previous node. The next pointer is always end. So when you add the new element at end. Okay. So now we go to delete operation. So this is the same example. The queue have only 2 elements, David and Robert. If you want to delete Robert and insert John, what happened? So we first retrieve the Robert. You first cut the connection. David and Robert connections were disconnected. So David next pointer point to John. Same as the John's previous pointer connect to David. Also the John's next pointer is null because there is no element after that. So this is a simple example for delete operation.